I hope that you are having a great weekend and and that you have a great week. I know things are kind of crazy right now. Obviously, you know that we're not having Think classes and we're going to be doing Think online for at least a few weeks, probably for the rest of the semester, and that's all a little bit crazy. But it doesn't mean that we can't still learn and have fun. So things are going to be a little different. What I'm going to do each week is I'm going to create a video where it's going to be me talking a little bit and then me showing you videos that I found online that are really awesome, just like we do in class. So it's basically going to be like class, except instead of being able to ask you guys questions and have you answer, I have created a little file online that you can access and type in your thoughts, and every week I'm going to summarize what everybody was thinking and saying and send it out to you as a little presentation. So in the message that I gave your parents, there was a link to what is called a Google Doc. And you don't have to have any special software to be able to use this link. You just click that link and it's going to take you to a web page, an internet page, that where on the left-hand side I have listed out some questions, and then there's two columns, columns B and C, where I've left just empty spaces for you to answer the question that's right next to it. So pick one of those empty spaces. Please don't ever delete anything else anyone else wrote. Pick one of those empty spaces, and whatever questions interest you, put in your thoughts and or some answers to the questions, or just something that you're thinking that is helpful and makes some sense, and sign your name to it. And if we get enough comments, then I'm going to collect them all into a little presentation that I'm going to send out either every week or at the end of the semester, depending on how many comments you guys give me and how active you are in there. So I hope that we'll have fun doing that, and it'll be a way for us to still kind of talk and get together without actually, sorry, I made a nice little page that I wanted to show while I was talking and I forgot to put it up. There we go. But it'll be a fun little place for us to kind of get together and share ideas without us being in the same room together. So I hope it's fun. I'm also going to be able to be assigning you some projects, and I hope that you'll do them and send them to me via email or texting so that, again, I can make little presentations and we're going to send it out to everybody. So I know this is different, and I know it's not as fun because we're not sitting around talking, but let's try to make it fun anyway. Sometimes things happen and we have to work around them. So this is just a thing that is happening, and we are going to find a fun way to work around it. So here we go. This week you were supposed to read pages 56 to 63 of your Hunting Aliens book. Now if you didn't, that's okay. But this is a really good time for you guys to catch up on your readings if you haven't been doing them. It's a fun book. It might be a little bit high level for some of you and probably a little bit low level for most of you, but it's still a fun read. I enjoyed reading it. And it has really great pictures. So if you've fallen behind in your reading, now that you're stuck home is a great time to catch up. See if you can read everything up until page 63, or even just finish the whole book. And then you'll be ready to keep on having discussions and posting in that little online board that I told you I'm going to send out later. So this week we're going to start out by talking a bit more about our solar system and how life evolved here. And then we're going to look outside of it a little bit. So I want to start out by talking about the sun. The sun is the heart of our solar system. So let's imagine, what type of creature might live in the sun? Hold on, I had a couple of little... There. Here's one. Here we go. I thought that was kind of a funny picture. Might be a creature that lives in the sun, right? Or what do we think about? Look at his little antenna. Love it. Good one. And here we go. Now here's a creature that I want to see living in the sun as long as I don't have to go anywhere near it. So think about it. You know, what kind of alien might live in the sun? Obviously, they are going to be really different from people, right? Because anything like a person would be able to withstand the heat and the radiation of the sun. And what might something that lives in the sun eat? I mean, nothing can grow in the sun. We know there's no plants or anything. There's no water. And as far as we know, everything that can survive or that lives has to have water. We've talked about that a lot. So really, nothing that we can even come close to imagining could live in the sun. So we're not really looking for sun aliens. It's fun to imagine. It's funny to think about, but we know nothing's living in the sun, and most likely nothing is living in any other sun anywhere else. There are some interesting ways that people might utilize the sun in a way that brings us very close to it. If you've ever heard of something called a Dyson sphere, it's basically a big bubble built around a star that is supposed to be able to capture the energy from that star. And it would be man-made or extraterrestrial made, and it's a really interesting comment idea. I will put a video of the Dyson sphere in the email that I sent out to your parents in case you're interested in looking into that. So anyway, while we're talking about the sun, though, even though we don't think that aliens really live on the sun, even this cool-looking, fiery, spidery-looking guy, it is good for us to know a bit about the sun, because the sun is basically the heart of our solar system. It is just the center of everything. So let's look a little bit. I've got a video that I want to play about the sun. Give it just a second here to load, and then I'm going to turn up my volume really high.
While billions of stars
and I hope you hear it
throughout the universe, the one at the center of our solar system plays a special role for us here on Earth. Our sun formed about 4.5 billion years ago in the Milky Way galaxy's Orion Spur. It was born when a cloud of dust and gas, known as a solar nebula, collapsed. And in the middle of this formation, matter condensed into a burning ball of gas that became our sun. The sun's fiery nature, along with a tremendous gravitational pull and an extensive magnetic field, helped it to become the heart of our solar system. The sun can be divided into 6 layers or regions: the corona, the chromosphere, the photosphere, the convective and radiative zones, and the core. In terms of atom count, the sun is about 91% hydrogen, the sun's fuel, 8.9% helium, and 0.1% heavier elements such as carbon and nitrogen. Due to the sun's extreme temperatures, these elements stay in a gas-like phase called plasma. In the core, temperatures reaching at least 27 million degrees Fahrenheit, combined with the sun's powerful gravity, fuse together hydrogen molecules to create helium. Called thermonuclear fusion, this releases an enormous amount of energy in the form of radiation, electricity, solar wind, and, as we experience on Earth, life-giving heat and light. Such volatility is contained thanks to the sun's tremendous gravity. It's strong enough to hold the solar system intact and is primarily due to the sun's size and mass. Our sun is the largest and most massive object in the solar system. It's more than 100 Earths wide and could theoretically fit all 8 planets inside nearly 600 times. It also contains approximately 99.8% of all the mass in the solar system. Because of this mass, the sun has a great pull on the fabric of space, creating a gravitational force that causes nearby planetary bodies to be drawn toward it. This gravitational pull allows the sun to hold together a system of 8 planets, potentially dozens of dwarf planets, at least 170 moons, and countless comets and asteroids. Without the sun's gravity, these celestial bodies would drift off into deep space. Another critical property of the sun is its magnetic field, which encapsulates the entire solar system. Called the heliosphere, this force field protects the planets from harmful cosmic radiation. It's caused by the sun's plasma pushing electrically charged particles toward the star's poles. This process turns the sun into a giant magnet. Although the sun's magnetic field is invisible to the naked eye, its effects are noticeable. On the sun's surface are dark areas called sunspots, which mark strong pockets of magnetism. On Earth and on some of the other planets, the sun's magnetic field interacts with their atmospheres, resulting in beautiful auroras. Despite its size and strength, the sun will not last forever. In about 6.5 billion years, it will run out of its hydrogen fuel, expand to envelop Mercury, Venus, and even Earth, and then collapse into a small star known as a white dwarf. In the meantime, the sun will continue to play a critical role in the system that bears its name. The sun's protective magnetic field, tremendous gravitational pull, and ability to create vast amounts of energy will protect, contain, and give life to our solar system.
There you go. Pretty cool, right? So, okay. Yeah, I thought that was a really good video. Beautiful pictures and great information. So I hope that you guys liked that one. So we've already talked a bit about the planets in our solar system in class. We've done it a little bit here and there, but I wanted to go a bit deeper onto a few of the planets in our solar system that could hold life, theoretically. So the first one we could talk about is the Earth, right? I mean, of course we know that the Earth has life. Obviously, we're here. But let's be sure that we understand a few basics about the Earth. Do you really understand the revolution, the rotation, the orbit of the Earth? You might already know these things, but I'm guessing that not everybody does, and even you might be able to use, if you think you know, you still might be able to use a little bit of a refresher. So let's watch this video to make sure that everybody understands these terms, revolution, rotation, and orbit, and that we really completely understand. It's just 4 minutes long, so let's give it a try. I hope you can hear it. I've got the volume up as high as I can. If you're having trouble hearing any of the videos, try earphones, and you'll probably hear them better.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night. Every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. Now here's the thing. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning?
Okay, so there we go. Now we know a little bit more about the difference between revolution, rotation, and orbit. I hope that you found that one interesting. So now let's venture a little bit outside of the Terran landscape. Terran, if you don't know, means Earth. So we're going to go off the Earth and we're going to talk a little bit about the moon. So, of course, the first thing, let me bring up my nice little picture here. The first thing that people, imagine back in time, imagine that you're an ancient. When people first looked up at the moon and they started to wonder about what it was. Why was it there? Believe it or not, a lot of people, you might have heard the joke that people thought it was made out of cheese. A lot of people thought it was very small. They didn't realize how far away it was. It was a big thing for humans throughout our history to try to figure out what was going on about the moon. I mean, imagine if you were a Stone Age person, or even somebody beyond the Stone Age when we could make bronze, but we still didn't really know very much and we didn't even have telescopes yet. What might you have thought when you looked up into the sky and saw this moon? Maybe you thought it was God. Maybe you thought it was a creature. Who knows? But now, fortunately, because of science, we do know. We know a whole lot more. So let's learn a little bit more about the moon. I have 2 videos about the moon. Well, actually 3 videos about the moon I want us to watch. The first one is, does the moon orbit the Earth or the sun? And you probably know the answer to that, and I believe you do. But let's look at the details of it a little bit.
Hey Joe, I was wondering if you could ask a video about why the moon orbits the Earth instead of the sun.
The moon and the sun are about the same size in the sky, which is why we get cool things like this.
An eclipse.
But that's just a coincidence, thanks to the fact that the sun is about 400 times farther away as the moon, and its diameter is about 400 times bigger. Get a little farther away, and the view is different. Still cool, though. The sun is big. We could line up 109 Earths across its face, and it's 330,000 times as massive. In fact, the sun holds 99.8% of all the mass in the solar system. But here's something weird. If we plug the Earth, Moon, and Sun into the formula for Newton's law of gravitation, we find out the Sun exerts twice the gravitational force on the Moon as the Earth does. So, does the Moon really orbit the Earth? Well, of course it does. We know this is true because we've measured the Moon and the Sun moving through the sky for hundreds of years, and we've also been up there. The fact that the Sun exerts more gravitational force on the Moon than the Earth does just doesn't matter here. Around everything in space, planets, moons, stars, is a volume where the gravity of the thing in the middle beats out the gravity from something farther away, even if it is more massive. It's called the Hill sphere. The Hill sphere around the Earth has a radius about 1.5 million kilometers, which is more than enough to fit the Moon's orbit. Now move the Moon farther away, or move us both closer to the Sun, and we'd lose the Moon. But that would be the least of our problems. The important thing is that inside the Hill sphere, the Earth's gravity dominates, and the Sun pulls on the Earth and the Moon together. So really, the Moon does orbit the Sun. It just orbits the Earth more. But what does that orbit look like? If I asked you to sketch out the path the Moon takes as it travels with Earth around the Sun, you might imagine something like this. But you'd be wrong. Imagine 2 cars racing around a circular track. One of the cars speeds up to pass the other, which is moving at a constant speed, then moves left and gets overtaken. It may seem like one's driving spirals around the other, but trace the paths and you get this. But the distance to the Moon isn't much compared to the space between the Earth and the Sun, so during our gravitational dance, those bumps smooth out to a very familiar shape indeed. Stay curious. What did the Earth say to the Sun when the Moon was acting all full of itself? It's just a phase.
Cute. Very funny joke. Okay, so that's really interesting, I thought. I mean, I knew that the Moon orbited the Earth and that the Earth was orbiting the Sun, but seeing just how that kind of works out, how it means that the Moon is kind of doing that little jumpy orbit that they showed around the Sun, Kind of interesting stuff. So now let's look at the phases of the moon. You might be looking at this video and thinking, oh my gosh, this looks like a really young kids show video, but it's got really great information about the phases of the moon. So if you know a lot about the phases of the moon and you want to skip forward 3 minutes in my video, go ahead. But I found this really interesting, and I hope that you will too.
If you ever look up at the moon in the night sky, say before you go to bed, you've probably noticed that as the days and weeks go by, the moon looks like it's changing shape. Some nights, it's a little sliver, and some nights, a few weeks later, it's a big bright circle. Well, the moon doesn't actually change shape, but our view of it does. Why? Well, the moon, just like the Earth, has a day side and a night side. A part that's facing the sun and a part that's not. So when we see a little sliver of bright moon, we're seeing a little part of the moon that's facing the sun, while the rest of the side that's facing us is dark. And the size and the shape of that sliver of lit up moon changes because the moon orbits or moves around Earth. It takes the moon about 1 month to make one full orbit around the Earth. And as it moves around our planet, the daytime side of the moon, the side that's lit up from the sun, is facing in different directions as we see it from Earth. This means that every night we get a slightly different view of the moon. And during its month-long trip in orbit around the Earth, the bright part of the moon appears to grow and then shrink from right to left. The different shapes that we see of the lit up part of the moon are called phases. And there are 8 phases of the moon. The first phase is the new moon. This is when the nighttime side of the moon, the side that's facing away from the sun, is what we can see from Earth. The moon is still up there, but because it's the dark side that's facing us, we can't see it during the new moon phase. The next phase is called the crescent phase. This is when the moon looks like a little sliver, kind of like the tip of your fingernail. After the crescent comes the quarter moon. This is when the moon looks like a half circle. And the next phase is called gibbous. A gibbous moon is when it's missing just a little sliver of light, and it's almost full. And that's what's next. The moon is at its brightest at the full moon. That's when the fully lit up side of the moon is facing us, so we see a big bright circle. But we're only halfway through our phases. After the full moon, the lit up part of the moon appears to shrink. And just like how it grew from right to left, the sunny side of the moon will shrink from right to left too. So after the moon is full, it starts to shrink back down to a gibbous moon. But this time, you'll notice that the left side is shining bright instead of the right. After the gibbous phase, the moon will look like half a circle when it reaches the quarter moon phase again. And then, after a few days, it shrinks down to a little sliver again, the second crescent moon. After that, the tiny sliver shrinks all the way down until the lit up side of the moon can't be seen at all. Now, the moon is a new moon again. It's the same old moon, but it's gone through a month-long cycle of phases, and it's ready to start all over. Like I said, it takes a month for the moon to go through.
So there we go. Now you understand the full moon and the phases that it goes through. We start out when there's no moon. You have what they call a new moon. Then as the moon gets smaller, it goes through all of those phases till it gets to a quarter moon, and then back the other direction, ending in then to a full moon, and then back the other direction until you get your next new moon. Isn't that interesting? I think it's pretty darn cool. Let me close off my sun monsters here so that when I want to, I can pull up my little logo. So I hope that you found that interesting, or at least just a refresher. So we talked about in class before about how we only see the light side of the moon. That when we look up into the sky, the view changes a tiny bit, but for the most part, we see the same side of the moon all the time, the light side. There is a dark side that humans can't see because that side always faces away from us, no matter where the moon is, compared to Earth. But recently, Chinese astronomers and astronauts were able to photograph the dark side of the moon. So we now know that there's no alien moon base up there, as some people used to believe. So let's learn a little bit about why we only see the dark side of the moon and what the dark side looks like. I'm going to play just 3 minutes of this video because it's kind of long, but I think that you're going to find these first 3 minutes pretty interesting.
Have a very good start.
The space race is back, and there's a new contender. In the early hours of this morning, China said it had boldly gone where none had ever gone before, landing, it said, an uncrewed spacecraft for the first time on the rugged and little-studied far side of the moon. The first image of the remote surface shows a crater within a crater, beamed back to Earth via a relay satellite. The Chang'e 4 probe will survey lunar geology, look for minerals, and conduct biological experiments too. Mission Control was delighted.
I think this is a milestone. Humans have never been there, but we did it. This is trailblazing. Building a space power is a dream that we persistently pursue, and we're gradually realizing it.
The far side of the moon has fascinated stargazers for centuries. The view we get of the moon from the Earth is always the same, though, because its orbit is locked to ours. This means that the time it takes for the moon to spin once on its axis is exactly the same time as it takes the moon to turn round the Earth once. Now, the moon's orbit is slightly elliptical, which means that from time to time we get a slightly different view. But 41% of the moon's surface, the far side, is always hidden from Earth's view. This is the conventional view, the near side of the moon, taken by this very telescope at the Royal Observatory in Greenwich.
We can't see the far side of the moon. That's the key thing. We're not going to see that from anywhere on Earth at any time.
China's claim of actually landing a vessel there has put the rest of the world on notice.
We have something on the far side of the moon. It's somewhere we've never been before. We don't know what information we're going to get. It's also part of sort of China's sort of strategy. It's another checkpoint. They've got loads of really sort of amazing ambitions. Maybe fairly soon, in some sense, we might have people on the moon again. So it's definitely an amazing achievement.
Although China's space program started
Okay, I'm going to go ahead and stop that there.
Eclipsed by the Russians and Americans.
There we go. So, yeah, pretty cool one there. We got to see pretty much, so it talked about how the rotation and the revolution of the moon impacts why we only see that one side. So the little bit of the video that we saw, they told how China has spent a lot of time and money trying to see the dark side of the moon. So just think to yourself, do you think that matters? I mean, think about it. Is it worth the time, money, and effort to try to see things like the dark side of the moon? What about the idea of going back to the moon? I mean, you all know that NASA landed people on the moon 40 years ago. Is it worth spending money to try to land people there again? Right now, NASA thinks so, because they are hard at work wanting to do another moon landing. Is this just repeating something we already did? Or is there value? Is it interesting? And even if we were there, we know that there's no people living on there. Nothing's living on the moon. If things were living on the dark side of the moon, we'd have picked up radio signals or something. So nothing lives on the moon. But could it? Think about it. What would an alien that lived on the moon be like? I mean, if something did, we know nothing does, but if something were going to live on the moon, what would live in a place that has almost no gravity, is dusty, that you could bounce off of if you jump too hard, that has it has some atmosphere but almost none? What might life be like there? It'd probably be a whole lot different than any type of life we know, right? So now let's go a little bit beyond the Earth and our moon, and let's look at a couple of other planets. One place that we've talked about and we've considered as a candidate for life are the moons of Jupiter. So let's take a look here at the moons of Jupiter. Well, okay, so I just deleted Mars from my notes because we've talked a lot about Mars. We already talked in class a whole lot about, if people lived there, we would be called Martians, which is hilarious, right? We've sent enough rovers to Mars that we know that there's no intelligent life there. We would have seen it. Unless, I think some of you believe that there could be life under the surface, and it's possible. And who knows, we could find all of a sudden, we could be digging and hit the roof of some building and find that there was a whole civilization on Mars thousands, even millions of years ago that has already died out and now the dust has covered it. It is totally possible that we could find something like that. Absolutely possible. Do you think? I think. Let me know what you think about that on that note file that I sent out. If you want to give some notes on, do you think there could be life on Mars? We can talk about that a little bit further. But now I want to jump over and I want to talk about one of the a group of places that have been a lot of candidates for life are the moons of Jupiter. Now we know chances are there's nothing living on Jupiter because there really is no on Jupiter. Jupiter is one of the gas giants. While it has a hard core, it's mostly made up of gas and storms, so nothing's going to live on there. But Jupiter has a number of moons, and some people think that some of these moons might hold life. And we've talked a little bit about Europa, but let's look a little more deeply. This is kind of a long video, so if you need to pause right now, you might want to pause and go get yourself a drink, maybe a bag of crackers or something that you want to snack on, because this is a 10-minute video, but it's super interesting, and it goes over a lot of the different moons of Jupiter. And if you're having trouble, I hope you can hear this. If you're having any trouble hearing and you don't want to sit and struggle to listen for 10 minutes, you can skip through 10 minutes of this video and then later just click the link and watch the video yourself, because I'm going to give you the links to all of these videos in case you want to rewatch them or you need to hear them better. So here we go. 10-minute video on Jupiter's moon coming up.
You by Squarespace. As we saw in the last episode, Jupiter is by far the largest and most massive planet in the solar system. That means it has a very strong gravitational field, which also means it can hold on to a lot of moons. A lot! Right now, as we record this episode, there are 67 that have been confirmed. And how many it really has depends on how small an object you're willing to call a moon. In 1610, Galileo pointed his telescope at Jupiter and witnessed a revolution. Oh, hey, literally. He saw 3 little stars lined up on either side of Jupiter. Stars he could not see with his naked eye, and they moved. A week later, he saw a 4th one, and he knew he was seeing objects revolving, orbiting around Jupiter. It was proof that not everything in the solar system revolved around the Earth. That was a pretty big deal. Those 4 moons are now called the Galilean moons in his honor. Not bad for a week's work. All 4 are really big, too. If Jupiter weren't there, drowning them out with its glare, they'd be visible to the naked eye. In that case, we might even call them planets, too. The biggest of Jupiter's moons is Ganymede. At 5,270 kilometers across, it's the biggest moon of any planet. It's even bigger than the planet Mercury. In fact, in size, it's halfway between Mercury and Mars. Size isn't the only planet-like characteristic of Ganymede either. It's mostly rock and ice, but it probably has a liquid iron core. It even has a magnetic field, likely generated by that liquid core. The surface is similar to our own moon in that there's very old crater terrain, as well as smoother, younger areas. Ganymede is also crisscrossed with large grooves. It's not clear what the origin of those grooves is, but it may be related to stress and strain on the surface, caused by the tides from the other large moons as they orbit Jupiter and pass each other. Ganymede has a surprise well below its surface too. Oceans of water. Measurements of Ganymede's magnetic field, made during multiple passes by the Galileo spacecraft in the 1990s, combined with Hubble observations of the moon, indicate Ganymede has quite a bit of salty liquid water deep beneath its surface. As we'll see in a sec, it's not alone in that regard. The next biggest moon is Callisto at 4,800 kilometers in diameter. In many ways, it's similar to its big brother Ganymede, mostly rock and ice. It probably has a rocky core, then a layer of mixed rock and ice above that. The surface is mostly ice, but mixed with darker material as well. It has a magnetic field too, but it probably doesn't have a metallic core. The surface is heavily cratered, and there's no indication of any volcanoes or tectonic activity. That means the surface is very old, maybe as old as Callisto itself. It even has an atmosphere, but it's a tad thin, roughly 1/100 billionth the pressure of Earth's air at the surface. Callisto orbits Jupiter farthest out of the 4 biggies, almost 2 million kilometers away. That's too far to gravitationally interact with the other 3. When I talk about the moons affecting each other, it's really the other 3 interacting. Next up is Io. It's only a little bit bigger than our own moon, and orbits Jupiter so tightly it only takes about a day and a half to go around the planet. When the Voyager 1 space probe passed Io in 1979, it revealed a surface that was really weird. It was yellow and orange and red and black, and didn't seem to have any obvious impact craters. An engineer, Linda Morabito, noticed that in one image, there appeared to be what looked like another moon behind Io, partially eclipsed by it. But that was no moon. It was a volcano on Io erupting, its plume shooting up from the surface and opening up into a wide arc. Io is the most volcanic object in the entire solar system, with over 400 active volcanoes. Quite a few of them are erupting at any given time, and images taken even a few months apart show changes in the surface due to ejected material. A lot of the erupted material is rich in sulfur, which is why the surface has all those odd colors on it. The energy for all this activity comes from the other moons. As they pass Io in their orbits, they flex it via tides, heating its interior through friction. A lot of that sulfur ends up as a very thin atmosphere around Io, and some of those sulfur atoms are then picked up by Jupiter's powerful magnetic field as it sweeps past Io and accelerates them to very high speeds. This has created a tremendous donut-shaped radiation belt around Jupiter, like Earth's Van Allen belts, but far more powerful. The radiation there is so intense it would kill an unprotected human in minutes. Of course, if you're floating in space near Jupiter unprotected, you might have some more immediate concerns. Oh, one more thing. Both Ganymede and Io are magnetically connected to Jupiter. Charged particles flow from those moons along the lines of magnetism to Jupiter, which then slams them down at Jupiter's poles, just like the Earth does with the particles from the solar wind. On Earth, this creates the aurorae, the northern and southern lights, and it does at Jupiter too. You can even see the ultraviolet glow where each of the moons connects to Jupiter, their magnetic footprints in the planet's atmosphere. And now we come to Europa, the smallest but perhaps most exciting of all the Galilean moons. Slightly smaller than our moon, it was known for decades to be very reflective, meaning its surface was probably loaded with water ice. But even so, the Voyager observations were shocking. They showed a surface completely lacking in craters, meaning something had resurfaced the moon, like Io or Venus, but Europa has no volcanoes. Even more intriguing, the surface was covered in long cracks, dark streaks all over the moon, as well as complex ridges. These and other features appear to be due to material from the interior of Europa welling up and forming the new surface, kind of like the way lava does on Earth. But in this case, the material is water. It's now thought that Europa has an entire ocean of water, sealed up under a solid crust of ice several kilometers thick. Water welling up and moving under the crust causes it to shift, creating all the various surface features. The amount of water that may be locked up on Europa is staggering, easily more than all the water in all the oceans on Earth. Like Ganymede and Io, the interior of Europa is kept warm by tidal flexing from the other moons, keeping the ice melted. Now get this, a lot of Europa's material is silicate rock, like on Earth and other terrestrial planets, located in a layer under the ocean. If this interacts with the ocean in the same way Earth's oceans interact with the seafloor, this could make the subsurface Europan water salty. In fact, those dark cracks on the surface have been found to be rich in salt and organic materials. In other words, carbon-based compounds. This is pretty exciting. We think Earth's life originated in salty ocean water. If there are carbon-based molecules actually in Europa's water, it's not too crazy to wonder if the same spark that occurred here also happened there. We think Europa has everything it needs to spawn life. We just don't have any direct evidence of it yet. Some people have proposed sending a space probe to Europa specifically to look for life. It would land near a crack in the ice where the crust is thinner and somehow penetrate it, perhaps melting its way down. Chemical sampling could then look for signs of biological activity. That's amazing to me. The idea of life in Europa, even if it's just microbial life, is taken very seriously by astrobiologists, scientists who study the possibility of life in space. It used to be science fiction. Now it's a topic of scholarly research. Astronomers have a concept called the habitable zone, the distance a planet can be from its parent star, where the temperature on the planet's surface can support liquid water. It's a fuzzy concept. Venus and Mars are both technically in the sun's habitable zone, but Venus is too hot and Mars too cold for liquid water. Atmospheres make a big difference, but it's still a useful concept as a rule of thumb for potential habitability. But Europa changed that. Jupiter is way, way outside the sun's habitable zone. Yet there's Europa, all wet. It's a great example that we need to let our ideas breathe a bit sometimes. Let them relax and flow outside the boundaries we set for them. When we look for signs of life on planets orbiting other stars, I bet we'll have to keep our minds open to types of life we've never considered before. Those are just the 4 big moons of Jupiter, each thousands of kilometers across. They probably formed along with Jupiter, coalescing from the eddies and whirls around the proto-Jupiter as it formed billions of years ago. But the planet has dozens of other moons, too. About the only thing they all have in common is that they're tidally locked to Jupiter. They all rotate once for every time they go around the planet. Jupiter's tides are hundreds of times stronger than Earth's, so no surprise there. The next biggest moon after the Big Four is way smaller. Named Amalthea, it's an irregular lump about 250 kilometers across its longest dimension. It was discovered in 1892, and it's red, probably polluted by sulfur from Io. It orbits just over 100,000 kilometers from Jupiter's cloud tops. If you stood on Amalthea's surface, Jupiter would fill half the sky. The moons get smaller and more irregularly shaped from there, with Himalaya and Thebe and Alara and Pasiphae, down to Hegemony and Kale and Kallichore, which are no bigger than hills. Many of the irregular distant moons of Jupiter orbit the planet backwards relative to the others in what are called retrograde orbits. They may be captured asteroids from the nearby asteroid belt. Many of the moons have orbital characteristics that are very similar too, which may indicate they were once a single object that broke up. Several such families of moons orbit Jupiter. The smallest moons we've seen are roughly 1 kilometer across. If they were sitting on Earth, they might be hard to pedal up on a bicycle. But orbiting Jupiter, they hardly rate as more than debris. There are probably thousands of moons the size of houses circling the planet. And who knows, maybe millions the size of tennis balls. Should we even call those moons? Maybe. But I don't really worry about that kind of thing. The important thing to remember is that these are worlds, big and small, each fascinating, rich, and diverse. And there's still a lot more left to explore about them. Today you learned that Jupiter has lots of moons, and 4 big ones. They're mostly rock and ice, though Ganymede, the biggest, may have an iron core. Io is riddled with volcanoes, and Europa has an undersurface ocean that is the object of intense study for scientists looking for life in space. Io, Europa, and Ganymede are close enough to interact gravitationally, providing a source of heat for their interiors. There are lots and lots of littler moons, but at the moment we really don't know much about them.
So that, I think, was a totally awesome video. I hope that you guys thought it was really interesting. Before I watched that video, I didn't realize how many moons Jupiter had and how far outside of the habitable zone Jupiter was. We've talked a lot about the habitable zone, and Jupiter and all those moons are way outside of it. Pretty crazy stuff. So I have another video that I wanted to play for you guys on the oceans of Europa, but it's 9 minutes long, so I'm just going to put that one in the comments in case you guys want to watch it. And then I have another really great one that it's kind of fun. It talks about like what different life and what other creatures could exist on other planets, but that one also is 9 minutes long. So I'm going to show you just a little bit of what this video looks like because I want to encourage you. So here we go. It's called 5 Impossible Things That Can Happen on Other Planets. We're going to, well, it's actually, okay, it's 7 minutes long. I'm going to show you one of them because I want to encourage you to click on that video and watch it.
There are some things that are just not possible on our planet. It would certainly be understandable that you would think that if it's impossible here on Earth, then it would be impossible everywhere else in the universe. But that's simply not the case, and the universe is far stranger than any of us can actually believe. Let's begin with shadows. Your shadow on Earth is always alone, and you're always used to seeing it this way as it follows you around during the day. You're also used to seeing everybody else with just one shadow, but this isn't a universal thing that would be experienced elsewhere. You have one shadow because our primary light source on Earth is our sun. But what would happen if there were 2 suns? A planet that orbits 2 stars would look much like Tatooine from Star Wars, with 2 brilliant sunsets each day and 2 shadows instead of 1 for each person. It used to only be science fiction until the planet Kepler 16b was discovered, which is a place that orbits 2 different stars. If you were suddenly teleported to the surface of the planet, you would likely die from the extreme temperatures and lack of air to breathe, but assuming that you were teleported in a suit that could help you survive, then you would experience having 2 different shadows, a friend for your...
So that's the video that I'd really like you guys to watch. It's called 5 Impossible Things That Can Happen on Other Planets, and I'm going to put that link, it's in the email that I sent to your parents, so watch that one because it's really good, interesting. There's 6 more minutes after what I just showed you here, and it gets really, really interesting. So think about it. Just in our solar system, we have a number of options of planets and moons that could hold life, and yet we haven't seen life yet, but it could still be hiding. There's probably not intelligent life in our solar system. We would probably know about that, but we've barely gone outside our solar system at all. There could be intelligent life in the solar system right next door. They might be as smart as we are, or maybe they're still in the Stone Age. I don't know. What do you think is more likely? Think about it. And then I'm going to ask this question again next week. For now, I want to give you guys a challenge. I have a challenge for you, and I'd like you to do this by Friday. So, and you have 15 more minutes left. We've only been doing this for 45 minutes, so you could take the time right now and probably do this challenge. So imagine that somewhere out in space lies a planet called T.N.K. This planet is a little bit smaller than Earth, and it has slightly less gravity on Earth, meaning that you feel lighter and you can jump higher and run faster. This planet is half water, half land. Its days are very similar to Earth as far as light and dark, but the planet has a much wider orbit around the sun. So in the summertime, it gets closer to the sun and it gets a lot hot. Almost even as hot as Florida or hotter. But in the wintertime, it travels further out from the sun, so the equator of the planet itself even gets snow in the wintertime. So imagine that. What type of creature might live on a planet like this? Think about how these creatures might live. What type of cities might intelligent creatures that lived in a planet that has a very Florida or Amazon hot summer and yet has a cold Alaska-like winter? What would life be like on a planet like that? So think about that, and then draw a creature or a city or a machine, like a boat or an airplane or a car, that might exist on a planet like this. And think about how the intelligent creatures on that planet, how they would have to live and how they would have to build things to exist on a planet where everywhere on the planet had such extreme temperatures. So create this either on the computer or on a piece of paper, and then have your parents take a picture of it and either email it to me or text it to me. And do that by Friday, because I'm going to take everybody's and I'm going to put them together into a little presentation. So that's it. That is it for class. So right now, if you want to watch more of the videos, the links are in that email. If you would like to, you could work on that little challenge that I just gave you. Or you can go into the link that I gave you where you can answer some of the questions that I've been asking and give me some comments. If you do choose to create a creature or a city or a machine, put your name on it and any information that you want to put on it to describe it. And I'm going to be creating a presentation if everybody gives me these to send out to everybody. So, and then don't forget to do your text reading for next week. Read as much of the book as you haven't read yet, all the way up to page, really all the way through page 79 to get ready for next week. So that's it. I hope that you guys have a great week. Stay safe, stay healthy. Keep on looking up the sky and looking for aliens. Oh, and by the way, I'm also going to put a link in the email so that if you want to, you or your parents can sign up for text or email links to NASA's Spot the Space Station. What this does is it just sends you a little text or an email every time the International Space Station, the ISS, is going to be visible from Tampa. Every time it's going overhead and you can see it, it will tell you exactly what time of day to go look outside and where in the sky you should look. And you can watch the space station go right overhead. You can totally tell it from a star. It is the neatest thing. So if you can, sign up for those alerts and start watching the space station, and we'll talk about that in the future. Have a fantastic week.